The height in inches of the 15 students in Jared's grade: 60, 65, 65, 66, 67, 67, 67, 68, 68, 68, 68, 69, 70, 70, 71, 74. What is the upper quartile, Q3, of these data? To find the answer to this problem, you must first organize the number set, find the median, and the median on either side of the median. Organized set is just all the numbers in order. Median is the middle number after all the numbers are in order. This is a thing that Jacob made. Hey, little Tooper, what you say? Let's do math. Okay. Let's do the box and whisker plot. Sure thing, Tooper. Start by putting the numbers in order. 60, 65, 66, 67, 67, 67, 68, 68, 68, 69, 70, 70, 71, 74. What's the mean, median, and mode? Mean is 67.8, median is 68, and the mode is 67 and 68. Good, you're not so dumb after all, Hobo. Yeah, cool, bye, Tooper. Find the median to either side of the median: 60, 65, 65, 66, 67, 70, 67, 67, 68, 68, 68, 69, 70, 70, 71, 74. Answer question. The heights in inches of the 15 students in Jared's class are... And then, what is the upper quartile, Q3, of this data? A, 67, B, 68, C, 69, D, 70. The answer is D, 70. This is an extra normal thing that I made.
Problem is really hard. Can you help me? What's the problem? The height and inches of its grade 11 science class are 60, 65, 66, 67, 67, 67, 68, 68, 68, 69, 70, 70, 71, 74. What is the upper quartile, Q3, of this data? Yeah, sure. Well, you see, you draw a box and a whisker plot. Oh, I see. Okay. Then what? Well, you put these points in order. All right. Thank you. This helped me out a lot. Then what you do is get the median, which is 68. So that means Q equals 4.3 plus 4.3 divided by 2 equals 4.3. And Q3 equals 4.75 plus 48 divided by 2 equals 4.75. Then you have to find the mode, and that is 68. Then you have to find the mean, which is 67.68. 8. Thinking now I might actually get to pass the test. Yeah, anytime, man. What you doing later? I don't know, probably going to Billy Bob Joe Enderman's to play Minecraft. No, don't go there, he smells like fart.
And I think that's it. No, we have one more video to watch.
Box and whisker. Box and whisker diagrams. And these are actually quite common, box and whisker diagrams, especially if you ever do any stock trading. If you go to most stock chart providers, a box and whisker diagram is usually one of the options. So let's understand how to generate one and essentially how to read one using just some data that we have up here. So the first thing we want to do is order it, because we're going to be finding a lot of medians when we want to generate our box and whisker diagram. So let's just order the numbers up here. So let's see, it looks like the lowest number here is 49. So I have that 49, then I have another 49 right here. Then I have another 49 right over there. And then, do I have any 50s? Yes, I have two 50s. Two 50s. I have two 50s. 1, 2. Do I have any 51s? I have 151 as far as I can tell. So 151. Do I have a 52? 52. 152. I have a 52. A 53. I have 153. Two 53s. 53 and 53. 54. There's one. 54, I don't have any other ones. 55, I don't see one 55 here. 56, I see a 56 right there. 56, and then 57. I have three of them. 1, 2, 3. 1, 2, 3. 57s, and I've got a 58, a 58, a 59, 59. Let me scroll over a little bit. And then I have a 67, and I'm done. I've ordered all of these numbers, and now it's a lot easier to find the median. Now, the median, as you may or may not remember, is the middle of these numbers. So how many total numbers do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 numbers. So the middle number, if you have 17 numbers, there's two ways to think about it. However many numbers you have, we have 17. You add 1 to 17, and you divide by 2, and you count that many spaces from either the left or the right hand side, and you will get the middle number. So this is 18 divided by 2, which is equal to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 53. Should work from this side as well. 1, 2, 3, 4, 5, 6, 7, 8, 9. You got 53. And if you ever have a situation where it's like, let's say you only had 16 numbers, and it would be 16 plus 1 divided by 2, you get 8.5. That means count 8 spaces and then go halfway between that number and the number right after that, which we saw that in a few diagrams before. But anyway, 53 is the median. 53 right here is the median. Now, the next thing we want to do when we want to generate a box and whisker diagram is figure out the median of the two halves of the data. Notice, if you pick 53 as kind of dividing line, half the data is above it, half the data is below it. If these are people's ages and they say they're 53, they're at the 50th percentile. 50% of the people are above their age, 50% of the people are below it. This is the middle number. What we want to do now is find the middles of the middles, or find essentially what is the 25th and the 75th percentile. So what's the number where only 1/4 of the numbers are less than that? And there's actually a little ambiguity here. So if I want to find the middle of this left-hand portion right here, it's debatable whether I want to include this median right here. And actually both of those are valid ways of generating box and whisker diagrams. The typical algorithm, an algorithm is just a way, a process for doing things, is to include this median in the bottom list and to include this median in the top list. So let's find the median of this list right here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 9 plus 1 over 2 is equal to 10 over 2, which is equal to 5. So we count 1, 2, 3, 4, 5 right there. That is the median of this bottom list, and we actually call this right here, we call this the first quartile. We call this the first. This number right here is the first quartile. And what it does is it separates, there's a bunch of ways you could view it. You could say that that 25%, or 1/4, that's where the word quartile comes from, you have 1/4 of the values are below this number. Or you could say 3/4 of the values are above this number. Now the other way to do a box and whisker diagram is you don't include this median, but I think you would have gotten the same answer. If you didn't include this median, you'd have had 1, 2, 3, 4, 5, 6, 7, 8 values. 8 plus 1 divided by 2 is 4.5, so you'd go 1, 2, 3, 4.5. So you'd go halfway between these two 50s, but you would still get 50. That's the number that's between a 50 and a 50. It's a 50. So either way, our first quartile number wouldn't be different. Now, the second quartile is the median. This is the second quartile. I always imagine you have 25. This is 25% of the numbers. 25%, or 1/4 of the numbers. It's the first quartile, or it's the first section, fourth of the numbers, and its upper bound is the first quartile. Then you have this 1/4 of the numbers, this is also 25% of the total numbers, but its upper bound is the second quartile, or it's the median. This is from the 25th to the 50th percentile. And then if we want to go from the 50th, this is 25th percentile, this is 50th percentile, which means that 50% of the values are below it. This means 25% of the values are below it. And then if we want the 75th percentile, we find the median of these values over here, and we'll include this median right there. So once again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. 9 plus 1 over 2 is 5. So you go 1, 2, 3, 4, 5. So the median of the higher half of our data set is 57. So this right here, this number right there, the 57, we call that our third quartile. Our third quartile, and it represents the upper bound on the section from our 50th percentile to 75th percentile. So that's 25% of our numbers there. You can imagine that's what's called the third quartile. 1 quartile, 2 quartiles, 3 quartiles. And of course, the number 57, you would say it's in the 75th percentile. 75th percentile, which means that 75% of numbers, or it is the 75th percentile, and 75% of numbers are below it. And if you count these, you would see that that's indeed the case. Anyway, so we've been able to classify some interesting numbers here. Let's actually plot it now using a box and whisker diagram. So what I'm going to do here, let me draw my x-axis just like that. It doesn't have to be horizontal like this. It could be in any form. So let's say that this right here is 0. That's 0. That right there is 100. Halfway between 0 and 100, I'm just making a scale right here, is 50. This right here would be 75. Right now what I'm doing has nothing to, well, it has, I want to include these numbers, but I'm just trying to make a nice scale to measure by. This is 25. And so let's draw this data using a box and whisker diagram. So the median is 53. So the median is 53. Maybe 53 is sitting right about there, right? That's right about 53. That's our median. Our first quartile is 50. So 50 is right there actually. Our third quartile is 57. So 57 might sit right around here. I might want to scale this a little bit differently. And I'm going to draw a box here. So this right here, that is 53. That right there is 57. That's 57. And that right there is 50. So what I'm essentially doing is representing the middle 50% of the data is in this box, and this line represents the actual median. Now, it's called a box and whisker diagram. I've only drawn a box. Let me draw the whisker, or the whiskers. The whiskers essentially show us the entire range of data. So the lowest data point is 49, which is right over here. I should zoom in on this a little bit. Highest data point is 67, which is maybe right over there. So we draw whiskers. So what a box and whisker diagram is showing us, it says, okay, most of the data is sitting inside of the box. 50% of the data, this 25% and this 25%, is within this box. But just to get an idea of the range of the data, it shows whiskers to show the low point all the way to the high point. Now let me draw this one a little bit. Let me zoom in a little bit because I realize that this is a little bit all squunched up. So let me draw it a little bit nicer. So let me change my scale a little bit. Let's say that this right here is, let's say that this is 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 7, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68. So this right here is 67. Where was 46, 47, 48, 49, 50? That's 50 right there. So if we use this as our scale, I think it'll be a little bit clearer what's going on with the box and whisker diagram. We have our median, our second quartile. Our second quartile is 53. 1, 2, 3, 53. It's right here. 53 is right there. Our first quartile, the number that is greater than 25% of the values, is 50. It's 50 right there. That's that. Let me color code it. this number right there